In this video, we are going to see how to test a differential relay using the automated test module. So if you click on this advanced menu, you have separate tab for differential where we have the transformer, generator and motor differential windows. So transformer differential is one of the complicated tests as it involves the vector group and different CT ratio with much calculations, which is implemented in a simplified manner. So let me show you how to do this. When we click on this window, you get an option like this. You have a line. On top of this line, you need to enter the nameplate details of your transformer, like MVA rating, the HV and LV. Let's take an example, 400 kV and bar 220 kV transformer, 100 MVA, and here based on this voltage and MVA I get the full load current. So let me have a 500 bar 1 amp CT, and a 1000 bar 1 amp CT in the LV. You can choose the vector group. So let me choose DYN11. Please ensure that the automatic computed single phase pickup factors matches the specific relay which you are using. So the automated single phase pickup factor is assigned here. In case it's not matching with the relay, this has to be edited, maybe 1.5 or something depending on the relay firmware. In case we use an interposing CT, we can enable it and enter the ratio or the multiplication factor here. We can also change the current direction by clicking on this arrow mark in case there is a mismatch in CT polarity. Nowadays this flexibility is available in numerical relays. To cope with that, we have this option here. Now below the line, we have the IED settings. So this area is for the relays. Your differential pickup, this has to match with your relay. Your trip time, operation time of the relay, pre-fault, level and time, the off delay. When we are injecting high current, so we need to create a time gap which is mentioned as the off delay. The through fault current, how much current you are trying to inject to simulate a through fault during the stability condition. Second harmonic content, the fault duration, how long you are trying to persist the fault, and in case you need a correction for ICT, whether it is required or not. Your tolerance level, this is for your results column. So depending on the feedback and actual time, it will verify with the tolerance to provide the results. If you are using third or fifth harmonic, normally we use fifth harmonic for overfluxing, that is V by F duplication. So you can select that fifth harmonic here in the nth harmonic content and enter the value in line to your relay. This section, slope through origin restraint equation and your unrestrained pickup, this is manufacturer specific, so we need to check with the manual and enter the value. However, Megger has a application note, a 21-page application guide, where for each relay what should be your line segment, characteristic method and your bias equation is fetched from the relay and a table is created. An example, GE make SR745 relay. The characteristics method should be selected as line segment. The bias equation is maximum current principle. So we select line segment and the bias equation as maximum current principle. So you have the list of universal restraint current principles available with the manufacturers. Depending on the manufacturer, we enter the value. After choosing this, we need to fill this table as per your relay settings. which is also guided here. What should be the value? So you have to enter the value given in these columns in red color with example. In this manner, this application guide provides you a complete idea on how the values has to be matched with your relay. For SEL make relays, what is your characteristics method and bias equation? For Siemens, for ABB, for Alstom or Schneider or MICOM relays. So in this manner, we will be able to fill out this table in line with the relay that we are testing. Then let's put a tick mark which shows how you have to connect your test kit to the relay. Then put a tick mark. It starts the first test called stability test, and the current that is going to be injected in winding 1 and winding 2 with phase angle is shown here. So when we run this test, there should not be any feedback, or the tripping should not be happening. If in case it trips, then either the setting that we entered is wrong, or it's not matching with the relay, or the connections is wrong. So when everything is perfect, you will not have any tripping, which confirms the stability test as passed. So using this button, you will be able to see the list of tests that will be carried out. Stabilization test, that's the first one. Then the timing test. The timing test will be carried out for single phase as well as 3-phase. So this is the place where you have to verify whether your single phase factor is matching with the relay. In case it's not matching, you can anytime go back to the main menu by clicking on this blue button and adjust the settings here for the delta and the star side independently. After completion of timing test, it moves to the pickup test, where it verifies the pickup for each and every phase and 3-phase for both the windings. Then we go for the characteristics test. This characteristics is drawn based on the values that we have selected in this tab based on this table. So this will match with the relay. So by clicking at various points, we get the table filled, and when we play, the relay will start injecting, responding to the values that are injected by the test kit, and it will verify whether the relay is operating on this red line. This green line is the tolerance, red line is your relay characteristics. Then we go for the second harmonic block test. So for each winding, it injects the second harmonic and creates a differential current and verifies whether the relay is blocking or not. So this is repeated for single phase and 3-phase for both the windings. And finally the nth harmonic. So this we have configured as 5th in the main screen. Since we have selected 5th harmonic, the nth harmonic is applicable for 5th harmonic settings. So that will be carried out in this test. So this entire test would be carried out within 15 to 20 minutes. So 100% your differential relay will be tested with these things without any calculation or human intervention. That's about the automated differential module.